EGFR is a proto-oncogene that has been linked to several cancers, including lung cancer. Overexpression of wild-type EGFR or EGFR mutations leads to oncogenic signaling and tumorigenesis. Currently, multiple generations of EGFR tyrosine kinase inhibitors, TKIs, have been clinically approved to directly target EGFR mutations and inhibit survival pathways. This ultimately leads to tumor cell death. Despite the unprecedented clinical success of EGFR TKI, recurrent mechanisms of acquired resistance or intrinsic resistance could strongly compromise the effects of these inhibitors. Therefore, the development of new therapeutic strategies to overcome EGFR TKI resistance is eagerly awaited. Inhibiting the EGFR kinase domain will ultimately lead to the occurrence of acquired secondary mutations, and cancer cells with wild-type EGFR do not respond to TKIs. Thus, an effective approach to eradicate EGFR by promoting degradation instead of suppressing kinase activity is urgently required. This invention introduces a novel natural EGFR degrader named Gmi, which is a medicinal fungal protein from Ganoderma microsporum, and it was first uncovered in Taiwan. Gmi physically binds to the extracellular domain of EGFR and subsequently promotes EGFR degradation. This eventually leads to a decrease in EGFR protein levels and induces cell death in EGFR-positive cancer cells. Moreover, Gmi effectively inhibits tumor growth and reduces EGFR protein levels in tumor-bearing mice with EGFR wild-type and activating mutations. This invention highlights the promise of Gmi as an EGFR-targeted degrader to combat EGFR-positive cancers and address currently unmet clinical needs.